This week we're studying exponents and scientific notation, and this is the PowerPoint for section 5.6, which is the section of your textbook that this goes along with. So we'll go through these slides and see what the new material is. And then I have some practice questions that I gathered from last semester's class, some of the questions that students found challenging last semester. What we'll be looking at are the properties of exponents, and you're going to want to kind of keep those nearby when you're doing the homework problems from this section, so you can either print them out or write them out, whatever makes more sense to you. We'll also be looking at using scientific notation and converting back and forth. So from scientific notation into decimal notation and then back in the other direction as well. And then we'll also look at using scientific notation when we're performing computations, add, subtract, multiply, divide, and then solving applied problems that use scientific notation. The properties of exponents that you want to make sure you understand are on this slide and on the next slide. And I think it's helpful to look at the examples to understand why these work the way that they do. And another thing that helps is for me to or when I was first learning this, was to write out kind of an example to see why this is true. So if you look at this product rule, think about if I have a simple number like 2 raised to the third power, and then I'm going to multiply that by 2 raised to the fourth power, for example. And so let's think about what this means. 2 raised to the third power means I'm going to take 2 and multiply it by itself 3 times. That's what 2 to the third power is. So we'll put parentheses around that to show that that's 2 to the third power. And then we're going to multiply that by 2 to the fourth power, which says take 2, multiply it by itself 4 times now. Okay. And now we look at this expression, and you can see we have 2 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times, which we know that we write as an exponent with 2 raised to the power 7. So what did we do here? We added the exponents. 2 cubed times 2 to the fourth means 2 multiplied by itself 3 times plus another 4 times, which is 7 times. So that's where that product rule comes from. The contrast of that, I like to first look at the quotient rule here. So if you think about let's do 2 again. If I have 2 to the fifth power, and if I divide that by 2 to the third power. So remember, 2 to the fifth power means I'm going to take 2, multiply it by itself 5 times. I'll write that over here. So 2 times 2 times 2, 5 times. And then I'm going to divide that by 2 cubed, which is 2 multiplied by itself 3 times. And then remember, anytime I have the same number in the numerator and in the denominator, so for example, I've got a 2 here and a 2 here, 2 over 2 is just 1. So these cancel out and I'm left with 1. I've got a 2 over 2 here again, so I can cancel these. Then I've got another 2 over 2 here. So in the denominator, I'm left with just 1. And in the numerator, I have 2 squared. So this is 2 squared over 1, which is just 2 squared. So you can see that we subtracted these exponents. And then here's the general rule. For the power rule, we'll do another example. So this time, let's just use x. Say I have x squared, and then I want to cube it. So what is x squared? That's x times itself twice. And then I want to cube that. So I'm rewriting x squared as x times x. And now I want to cube that. And what happens when I cube this? Well, I have to take x times x and multiply it by itself 3 times. Now I've got 1, 2, 3, 4, 5, 6 x's, or x to the 6th. And you can see that I multiplied the exponents. So this is where these I don't really even like to call them rules. I like to call them properties because we didn't just make up some arbitrary rule. This is how the math works. So these are properties of exponents, but sometimes also called rules as well. See if I can get this to move where I want it. There we go. Okay. Another very important property of exponents is that if I take any real number other than 0 and I raise it to the 0 power, that's equal to 1. And some students struggle with this. I remember in particular, my youngest daughter really struggled with this because she didn't like the 0 and the 1, and it seemed sort of arbitrary to her. But if you think about, let's think about 2 again. So we know that 2 to the first power is just 2. And 2 to the second power is 2 times 2, or 4. And then 2 to the third power is 2 times itself 3 times, which is 8. And so do you notice that as we get bigger, as the exponent gets bigger when we're moving down, the number gets multiplied by 2. So when I go from the first power to the second power, I'm multiplying the previous one by 2. So in order for this to work, I can't have 2 to the 0 be 0, right? Because then all of these would have to be 0. But if 2 to the 0 is 1, now look how this works. Now I go from here to here, and I'm multiplying by 2. And also notice that when I'm going in this direction, I'm dividing each one by 2 to get to the previous one. So if that helps, this kind of helps me to understand why 2 to the 0 is equal to 1. Another way to think about it is if you think back on that previous slide, we saw that a to the n over a to the m is equal a to the n minus m. So in other words, when I divide, if I have the same base, I can subtract those exponents. So now let's think about 2 again, although it doesn't have to be 2, could be any number. But what if I have 2 to the 5th over 2 to the 5th? Well, we already know that any number divided by itself is 1. So on the one hand, we know that, but we also know from this property of exponents that when we divide, we can keep the base the same and then subtract those exponents. So that means this has to be equal 2 to the 5 minus 5. And of course, 5 minus 5 is 0. So this has to be equal 2 to the 0 power. So both of these just kind of help, I think, explain why that property is what it is. And I like to know why. Helps me to remember things. So we can apply this 0 product property. So 7 to the 0 is 1. We said anything to the 0 is 1. So that means 7 to the 0 is 1. Pi to the 0 is 1. We said any real number. Pi is just a real number that has a lot of digits, an infinite number, actually. It also works for negative numbers. So -5 to the 0 is 1. Now on D, remember, we have to think about our order of operations. So for part D, remember, this is the opposite of 5 to the 0. Even though those parentheses aren't there, they're sort of implied. So what do we do first? The exponent happens first. 5 to the 0 is 1. Then we have to take the opposite. So that's why this one is -1, but this one is +1. Then we have our negative exponent property, and this comes from what I was showing you in the previous screen where we said 2 to the 0 is 1, and 2 squared is 2, and 2 cubed is 3. Oops. I am just going off on that. Let's fix that. That's not true. Here we go. Let me just undo that. 2 squared is 2 times itself twice, which is 4, and 2 cubed is 2 times itself 3 times, which is 8. So as we go in this direction, we're multiplying by 2. Multiply by 2. And when we go in this direction, we're dividing by 2 to get from one to the next. So if you think about going from Oh, I forgot 2 to the first. I really was just kind of rushing there. Okay, there we go. Oh, now that looks all wonky. Well, I'm going to rewrite that. I'm just going to start this over. Okay, so 2 to the 0, that's 1. 2 to the first, just a single 2, so that's 2. Anything to the first power is just itself. Squared, I multiply by itself twice, and we get 4. And then cubed, 2 times 2, 4 times 2 is 8. So as the exponent gets bigger, and I'm moving in this direction, I multiply the previous number by 2. As the exponent gets smaller and I'm moving in this direction, I'm dividing the previous one by 2, which means if I'm going to decrease from 0 to -1, right? That's just decreasing that exponent. I'm going to divide by 2. So 1 divided by 2. And so that's where this property comes from. And kind of a way I have of thinking about this is that thinking when we jump over the fraction bar, we change the sign, because I can think of this as over 1. It's another way of thinking about that. And so that means then that 1 over b to the negative n, okay, that's going to be b to the n, okay? So when I come across the fraction bar from numerator to denominator, the sign of the exponent changes from negative to positive. All right, so we can simplify some things here using that negative exponent property. So 8 to the -2, using that property, we know that it's 1 over 8 squared. And so then we can just rewrite that as 1 over 8 times 8, and that's 1 over 64. 5 to the -3 is going to be 1 over 5 times itself 3 times. So 1 over 5 times 5 times 5, which is 1 over 125. And notice that 8 to the -2 is a positive number. It's a small positive number, but it's not a negative number. 5 to the -3, also not a negative number. So this negative sign here just means that we are going to move the exponent into the denominator if it's in the numerator, or the other way around. Oh, hello, Rachel. I just noticed you had joined us. I've been just chatting away. Do you have any questions for me?
Um, yeah, I had a question about this one problem on the homework, and I understand it, but I keep getting confused with how to move the decimal point, because I always add an extra zero when I'm counting it out. It's this
Let's
problem
do
is
that one. Is that a scientific notation question?
yeah, it's 6.34 times 10 to the ninth, and then it's what is it in decimal form?
Uh-huh.
And so when I did it, I went I started at the decimal point and then I counted 9 places, but I did an extra zero from the answer. The answer was I think it was 6,340,000 or something, but
Oh,
I added an extra
yeah,
zero.
I went backwards. What am I doing here? Okay. So, so, um, so in other words, I'm just going to put these in to help me. If you kind of think about where that decimal point was in scientific notation, it was right here, right?
Mhm.
So that means that on the other side, I need to have 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
But it was to the ninth power, so wouldn't it be nine digits,
Oh, I'm
right? Or
sorry.
no,
Yes,
it's
I
okay. Don't
erased
worry.
that. You're right. Yes, let me fix that. Let me just erase. I see what I did here. Okay,
That's the answer I
so
got the first time, and it was wrong. Because I did an extra zero, but I don't like the way my thought process is. It's when I do it, I always get that extra zero. So I don't know
okay,
why.
so So think about, okay, so that's the number that we should get.
Yeah.
And if you think about where the decimal point was, it was right here, yeah?
Mm-hmm.
So the number of decimal places that I should, or digits that I should have is whatever this number is. So that means I should have 9 digits over here.
Mm-hmm.
Another way of thinking about it is if you start with the
Oh.
number and then you're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. So
I
this
think
tells
I
me
need to do it the way that you did it the first time. Cause like
I like,
that makes
yeah,
sense to me more. Like
I like
sometimes
this way.
I think it's when I do like the little loops, like it like confuses
Oh,
me. Like
yeah,
I'm so,
see, I don't love the loops either. Some people like them, but
huh.
yeah, I kind of, it's easy to miscount or to skip a zero. But so like one way I kind of think about it is I write it out and then I always count those digits one more time.
Mhm.
So I might think I'm getting it right, but then I always come back and I don't necessarily draw the line and do that, but in my head, I double count these and make sure that I got whatever that
Mhm.
number is. Yeah.
Okay, that makes sense.
Because it's when it's such a high power, it's easy to drop a zero or add a zero. So I like
Yeah.
to check my work. Yeah. Okay. Other questions or do you want me to continue?
Um, I just want to clarify like this one question I had.
Yep.
It was 0.655 in scientific notation,
Mm-hmm.
and it was 6.55 times 10 to like the negative 1 power. But like I just want to know how that works. Because like I
Yeah.
understand it, but like I need like I don't know, I just want like more clarification.
Yeah. So for this one, I know that I need to move the decimal point so that I only want one digit here, and then I want the rest of them here, right?
Yeah.
So that's how I come up with this.
Hmm.
And then the only thing I do is I say, well, how many times did I move it to the right? That's the number that I need here. And I know that it needs to be negative because this number was less than 1 when I started.
Oh, right.
Negative
Yeah.
1. And another way
Hmm.
that I think about it is I kind of check my work. Is then I
Hmm.
go, well, what if I wanted to write this one? I'm going back to
As like a
scientific
decimal.
notation.
Uh-huh.
If I'm going back to scientific notation, I know that I need to move the decimal that way
Hmm.
to get 0.655. So then I can think about where was kind of like we did in that other one, where was the decimal point originally? It was here.
Hmm.
So how many places? Now I need those places to be to the left of my line. So I need 1 to the left to get to where the decimal point is.
Okay. That makes sense. Yeah.
Good.
Yeah.
Okay. So let's see what other properties of the other thing. Well, so the main things to keep in mind with your powers of 10
Hmm.
is that whatever number we have here, that's how many zeros are after the 1. So 10 to the ninth, that's a 1 with 9 zeros.
Hmm.
For negative exponents, it's similar, except for, again, we're going to think about if the decimal point was here instead of over here,
Hmm.
there should be 9 digits in between there. 3, 6, 9 digits.
Hmm.
Okay. So 10 to the negative ninth is point all of those. So I got to have
Yeah.
all of those digits. So that helps me to understand those powers of
Hmm.
10. And then for scientific notation, you just want to make sure that your number that's out front has to be 1 or greater and it can't be greater than 10. And another way of thinking
Right.
about that is it can have a decimal point and have as many digits as you want, but you can only have one digit on this side. You can have as many digits as you want on the right, but you have to have exactly one digit over
Yeah.
here, which is kind of what this is saying.
With the like when you write it in decimal or like when it's like a negative exponent, like does the zero outside like on the other side of the decimal, like does that count as a digit or no? Is that just
No,
like a
that's just a
placeholder?
placeholder.
Okay.
Mhm. So the 0 to the left of the decimal point is a placeholder. It's not
Okay.
counted in those digits. Good question.
Okay.
Yeah. Uh-huh. Okay, and then yeah, a positive power of 10, we're moving the decimal right, a negative power, moving it left. Okay, so here's some good examples. So again, for A, I just kind of start with, whoops, lost my pen. There we go. Okay, so I just start writing the number and then I count. Okay, I've written 3 digits, right?
Hmm.
I need 10. 4, 5, 6, 7, 8, 9, 10. Then I backfill with my commas so it's easier to look at the number. And then, like I said, I don't draw this line, but I think about if I did draw the line back where this was, and then I count and make sure I have 10 digits.
Hmm.
And then for one like this, so I'm going to think I need to move the decimal 4 places. So in order to get 4 places, I've got to have 1, 2, 3, and then I have that 1 that I originally had. So
Would
I
be
kind of,
0 point.
yeah, and then you can put
Okay.
that leading 0.
Okay.
Yep. So this one here does not count. It's only these zeros that come after the decimal point that
Hmm.
count. Yep. Okay. Yeah, what else have we got in here? I think, oh, okay, so if we're going in the other direction, we're just going to think, what are the significant digits? So we drop all of the zeros and we make sure that we only have one digit on that side. So how many extra digits do I need to add in to get back to this number?
5, right?
So I moved the decimal point all the way over to
Mhm.
here, and it was originally over here. So how many places did I
Oh,
move
would it
it?
be 6, right?
Yeah, yeah.
Okay.
Hmm.
There's 6 pounds because it's on the other side of the decimal.
Yes. Uh-huh. And then for this one, again, I think about, I just want one digit over here. I want all the other digits over here. And this one, I'm moving the decimal point to the right. And how many places did I move it from here to here?
5, right?
Yep. So 10 to the
Okay.
negative 5. Yep. Hmm. And then, oops, I think, yeah, lots of words. Okay. So then
Mhm.
we can do like multiplying is where it becomes really powerful because I can just change the order. Remember, when I multiply, I can multiply whatever order I like. So I can multiply the number parts together
Mhm.
and then the power of 10 parts together. What
Yeah.
often happens though is I end up with a number that's no longer in scientific notation. So then I have to make an adjustment. This one doesn't cause a problem. So this one I would just do the number part, so 3.4, I mean, they're all number part, but the decimal number parts. And then I'm going to do times and then 10 to the ninth times 10 to the negative fifth. And then 3.4 times 2 gives me what?
Mhm. Is it 6.4, right?
6.8, yep.
Oh, 6.8.
And then what property do I use to multiply these two?
You add, right?
Yes. So that gives me 10 to the,
-4.
so I got
-4, right? Oh, wait,
positive
no,
9.
4.
Yes, that's right. Exactly. Okay, so that one worked out nice, and this number is in scientific notation because it
Mhm.
meets that definition that we have. So I don't really have to do anything else. Did I put, oh, and we can do division. Okay, same thing. Where's my example? Here. Okay, yeah. I want to do an example of one where I have something like 4.52 times 10 to the ninth times 7.213 times 10 to the fifth. Okay. So again, I'm going to change that order, and I would probably use a calculator to do this part. See what that is. I've got my calculator right here. 4.52. Whoops. Times 7.213. Okay, so I get 32.60276.
Mhm.
Okay, and then what do I get for my powers of 10?
Is it 10 to the 14th, right?
That's right. Now, hold on. I realized I hit the wrong button here, so I'm trying to switch back to here. Okay, so yeah, times 10 to the 14th. Okay, so is this number in scientific note? Well,
Mm.
is that number in scientific notation?
No, you have to move it one to the left, right?
Yes, yes. So I first have to write this as 3.260276 times 10 to the, so I
Would you
move
add it, right? Like you'd add
yes,
one?
yes.
So like if you had to like add one decimal to like the right, would you subtract one?
Oh,
Or would you
okay.
even have to do that? Like,
Yes. So
okay.
let's do, for example, 4.52 times 10 to the fifth divided by 7.2 times 10 cubed. Okay. So now I'm going to do 4.52 over 7.2
Mhm.
times 10 to the fifth, or to the 5 minus 3, right?
Yeah.
And then what is 4.52 divided by 7?
Point
4.52,
six two, something like 77777.
and we'll just call it
Seven.
0.628. We'll just round it to
Okay.
there. And we only had 2 digits here, so that's more than enough. And then that's times 10 to the second, right?
Okay. Yep.
Now, this number is not in scientific notation, right?
Hmm.
So how do I get this number in the right form?
You move it to the right one.
Yes. So if I move that to the right, then what am I going to do over here?
Subtract it.
Yes.
One.
Yeah, or I could just do 6.28 times 10.
Hmm.
And that's not really a number that I would probably write in scientific notation, right?
Hmm. Yeah.
This number is just easier to write as a regular old number, 62.8. But that's probably the most challenging part about scientific notation is just remembering that I have to convert it. But it sounds like you get
Hmm.
that. Yeah, it sounds
Yeah.
like you have
Yeah.
that
Because I
down.
got one. Yeah, I got a problem wrong on my homework, and I was like, "What did I get wrong?" Like I was getting so frustrated, and then I just like looked, and I was like, "Oh,
Now
now I
you
get
have
it."
it.
Yeah.
Good. Fantastic. Any other homework problems?
No, that was all I had for the most part. Thankfully, like this part is not that hard for me, like the exponents and scientific notation.
Mm-hmm.
It's like one of the easier concepts for me to
Good.
understand, which was
Good.
good.
Very straightforward. Yeah.
Yeah.
What about did you have a problem like this one? Let's see, 3 to the fifth times 3 to the negative fifth and 4 to the eighth. times 4 to the negative 8. So
Oh
if I
yeah, and it
wanted,
was like which one, like is it bigger than the other, like equal?
yeah, what is it?
It would be equal
Yes, why?
because like five plus wait, yeah, 5 plus -5, that's 0, and then 8 plus
Yes.
-8 is 0, and then that like any number to the 0 power except for 0 is 1.
Very good. Yeah, that was one of the problems that was most frequently missed last semester. So good.
Mm.
Yeah. Excellent. Any other homeworks or anything? What about did you get a chance to look at the quiz?
I think I did look at I think I just did it one sec. Let me see. I can't remember if I did the homework or the quiz.
This
Um,
was a section from last semester where the overall scores were pretty high. So not a lot of, I think it is pretty straightforward.
mm, oh no, I didn't do the quiz. Yeah, that's like for the modules 1 through 5.
Yes. Yeah. So that's it. Let's see, we're in week 6. So week 8, we have our first exam. So that quiz is a great way to kind of see
Hmm.
what what do I remember in modules 1 through 5. And then if you're feeling pretty comfortable with that, that puts you in a really good place going into the exam. And if not, then you know
I'm
what you need to,
nervous.
yeah,
I always get nervous for tests.
okay. Have you practiced any techniques for calming yourself down?
Yeah, I just try to like tell myself like you know what you know. 'Cause, like last semester, like at my junior college, I did like chemistry and like a bunch of hard classes, so like I didn't think I would pass. So I just like try and think like if you could pass those classes, like you can pass this one. And like
Yes.
my chem teacher told me like if you're nervous, it just means you care. So just like put that nervous energy into like something. So I'm just like trying to like put all that energy into like studying and like
Yes.
with confidence is key. Because then like I don't want to second
Yes.
guess myself on the test and stuff.
Yeah, coming in prepared is the best way to beat that. And then if you
Hmm.
do find yourself panicking, even just give yourself a minute to take like 3 really deep breaths. Make sure you exhale
Yeah.
all the air because that will bring your heart rate down and get your brain to calm down. And then you can start thinking about the subject again instead of,
Hmm.
yeah. Yeah.
Could I ask a question about like this is not conversion, but
Hmm.
like I was just going through like it was like a question that was on like the discussion post, like you know how we have like numbers and we have to like
Yes.
I was just
Uh-huh.
going through those as like a way to practice, and it was like
Uh-huh.
9 quarts equals like how many fluid ounces, and like I was using the exam, like the sheet of like conversions that we could use on the exam,
Yeah.
and like it doesn't give
Whoops.
us like the conversion for like 1 quart equals like 32 fluid ounces. So like I did like quart to
Yes.
liters to milliliters, and then from milliliters to like the
Oh,
fluid ounces. But I got like
yeah, that
three
so
digits
so
off from.
I probably wouldn't do it that way because that's going to maybe introduce some rounding errors. So
Hmm.
I think when if you're because fluid ounces and quarts are both part of the standard system, I would convert. So what were some of the factors that we had? Like, do we have quarts to cups and cups to fluid ounces?
Let me look real quick. Uh, so there's like, is it like the conversion factors for volume, right?
Yes. Uh-huh.
So there's there's like cups to liters, quarts to liters, gallons to liters, and then for the fluid ounce, it's to milliliters. That's why like I was like using the milliliters.
Let me see. I thought, hold on, I'm gonna jump out of this for a minute here, if I can get it
Okay.
to agree with
Oh
me.
wait, there is a cup. Yeah, they do have the cup to fluid
Okay,
ounces.
so what do they have?
They have 1 cup to fluid ounces, like 8 fluid ounces, and they have a gallon to fluid ounces too.
They don't have quarts to cups or anything?
Or unless I'm missing, I only see quarts to like liters and quarts like
Okay,
4 quarts to
yeah, let me
15
just pull it
gallons.
up so I can see, because maybe,
Maybe I'm not looking in the right area.
okay, let me see if I can find. Have it in here. Okay, can you see that, or was it only shown? Can you see the
Oh
conversion
yeah.
factors? Okay,
Uh-huh.
so that's not what we want. Standard to metric. Oh, this is the wrong one. Whoops. Hold on. That's the old one. Um, this is the one. Okay, so volume. Yeah, here we go.
Mhm.
So, we kind of have to work with what we have. And we want to do 9 quarts, right? And we want to get
Mhm.
fluid ounces.
Yeah.
Okay. So, and my goal is to end up with fluid ounces. And
Yeah.
so I have, let's see, I have quarts to gallon and I have gallon to fluid ounces. So that's probably what I would do then. So if I convert quarts to gallons and then gallons to fluid ounces. So I have 9/1
Mhm.
quarts. And then I'm going to
Times.
multiply by the unit multiplier using these two. And I
Would
want
be
to
times
convert,
1 gallon
yes, so 1 gallon over
over
4
4 quarts.
quarts. And then I'm going to use this one.
If you then it'd be 128 fluid ounces
Mhm.
over one
Yes,
1 gallon. Okay.
right.
So they
Now my
cross
quarts
out.
cancel, my gallons cancel. Have, was it 288, I think?
Yeah. Okay. Yeah. That was the answer like they got on the discussion post and like what I looked up too. So that makes a lot more sense now. I think I was just
Yes.
overcomplicating it.
Yeah, so just look and see, like a lot of times you'll have like, we'll have a conversion factor from quarts to fluid ounce, but we didn't, so we just have to
Mhm.
combine a couple of them. So just kind of
Yeah.
see, but don't mix. If you're converting from metric to standard or the other way around, then of course you have to use one of those conversion factors. But if you're converting within standard, stick with standard, and if you're converting within metric, stick with metric, and you'll just, otherwise you might introduce rounding errors.
Mhm.
And then come up with something different than what they were looking for. And then just don't forget do you have a printed copy of this?
No, but I'm gonna print it out for the
Yeah.
exam, right? Because yeah, we need it.
Yes, make sure you have a printed copy of that because have you used the lockdown browser before?
Yeah.
Okay. Yeah, so and the system is pretty strict about when you start up the test, it wants to see your environment. It wants to see that
Mhm.
you can have a couple pieces of scratch paper and you can have your couple pages of notes and that's it.
Mhm.
So just make sure that
Do you know when like she's gonna or like the teachers are gonna like because I know certain like like when I would have notes in my chemistry class, like it would be like certain things are like allowed on notes, like we're not allowed to like write actual problems. Like, are they gonna have like an announcement about that? So, like I know like what I can put on there.
Um, this semester, the only real thing that we're having is that
Mhm.
it has to be 2 to 3 pages.
Oh, okay.
So no more than 3 pages. And that doesn't include your conversions. So,
Mhm.
but there's not
That's-
really anything about what you can and can't have. So just
mhm.
use whatever notes you have. We're switching actually next semester to where I think what we're going to do is supply
Oh no,
everything so that everybody kind
uh,
of has the
the same
same.
thing.
Yeah. I'm not sure. It's kind
Yeah.
of,
Well,
yeah.
that's good. Like 2 pages, it's a lot. Even three, like
Yes. You
it's
don't
a
even have
lot.
to write teeny tiny. You can just make sure you have
Exactly.
everything that you need to know to, yeah. Yeah,
Makes me
I
feel
think that's
better.
plenty. If you,
Yeah.
because I've taught classes where, students were allowed to have as many notes as they wanted. Well, then sometimes they just don't prepare as much as they should. And
Hmm.
then it's not really helping you out because if you're having to shuffle through pages and pages of notes, then you're,
That's
losing
true.
time.
It kind of confuses you more than it even helps you a lot
Yes,
of times.
right. Yeah, having it organized is the way to go.
Hmm.
Mhm. All right, anything else you want help with?
Um, maybe this one, it's like how many cups are in 8 and 3/4 gallons?
Okay, so we want 8 and 3/4 gallons and we
Hmm.
want to convert to cups.
Yeah.
Okay, so let's see. I've got gallons to fluid ounces and cups to fluid ounces. So this looks like the way to go, doesn't it? Using these two.
Hmm.
So 8 and 3/4 gallons. And then what do I want to multiply by?
Like one or gallon, it'd be 128 fluid ounces over 1 gallon. And then times 1 cup over 8 fluid ounces.
Looks good. Gallons cancel. Fluid ounces cancel. Good.
Mhm.
So I have 8 and 3/4 times 128 divided by 8, something like that, right?
Yeah.
So you have some options here. If you want to do the arithmetic yourself, then you can make this a improper fraction, and then you can simplify this and so forth. We can also just use Desmos. Let me bring up, whoops. Can you see Desmos now?
Yeah.
Oops. It didn't do what I wanted it to, though. Hold on.
Mhm.
I wanted to see both. There we go. Just move it over here like that. Okay. So back to here. So with Desmos, I can just do 8. Let's see if it'll do 8 and 3/4. I don't know. No, it doesn't like that. But there's like an implied plus sign here, so I can do that.
Mhm. And that's like the
E-
decimal. Yeah, because that's what I did like first. I
Mhm.
like I made it like a improper fraction and like I divided to like make the
Mhm.
decimal because I like thought that'd be like easier when I like converted.
Then we can just do times 128 divided by, whoops, we want to make sure the 128 is divided by it probably doesn't matter, but just to make sure. There we go.
Okay, that's what I got. Perfect.
Mhm. And yeah, I mean, it's not too bad, like, because this as an improper fraction would be, let's see, 8 times 4 is 32, so that'd be 35 over 4. Whoops, why did I write 8? Because I was thinking ahead. 35 over 4 times 128 over 8. And then, I can do some simplifying and so forth. But there's nothing
Mhm.
wrong with pulling out Desmos and doing it that way.
Okay.
So yeah, because
Okay.
this would simplify, what's that, 32, and then that's 4. So yeah, that's not bad at all. But yeah, I mean, on an exam, you're allowed to use it. Nothing wrong with making sure that that's the
Just,
right
yeah.
calculation. All right,
Mhm.
you got any more?
I don't think so. I think I
Okay,
just need to keep like doing the repetition part of it. So I get the hang
absolutely.
of it more.
Yes, that's always great.
Yeah.
Good way to go. The more practice, the better. Overstudying, that's
Hmm.
the way to
Yeah.
succeed. Unfortunately, there's not really any
Other way
way
around
around
it,
that
literally.
when it comes to math.
Hmm. Even if you
So,
have like a bunch of notes, like it's like each problem is
yeah,
like specific to like its own too. Like you have to know how to like apply the concept to that specific
right,
problem.
right. Yep. But it sounds like
Mm.
you're doing a lot of preparing, so good for you.
Okay, yes. Mhm. I want to
Yep.
do good. I want to keep my grade like an A.
I like it. Good for you.
Mm.
All right. Well, if you think of anything else you need help with, make sure to reach out to me or someone else that can help you.
Mhm.
Lots of us out there.
Yes, I will.
All righty. I hope I see you next week.
Mhm. I will.
Bye.
I'll see you next week.
Okay.
Bye.
Bye-bye.